Good evening, everyone. Today, I'd like to talk about system libraries. There are three of them: called efficient call, system contract helper, and the system contract caller. So let's look at the first one over here. This is actually used to make some low-level system call, including the raw call, raw mimic call, raw static call, raw data call. In the beginning, they also include two hash function, which is making two system call using these special edges over here as the system call router, because you see this, you know which one to call. So I'm going to focus on the raw call and the static call, dynamic call, and mimic call. These four kind of call. All of them is going to make a low-level raw call first, and then going to verify the call result, which essentially is just copy the return data to the zero edges. When for the successful case as well as for the unsuccessful case. In the case of unsuccessful, it's going to propagate revert, which is going to revert on the error message, and the error message is supposed to be in the return data, which is copied to the zero edges. So I will focus on the call itself. For example, let's look at the call, which is called raw call, and this one is have most number of arguments: 1, 2, 3, 4, 5 arguments. And the system call only have a 3. The direct call have a 3. So mimic call also have 6. So let's look at the raw call. The raw call essentially is going to load the file call API into ActivePDR first, which takes 4 arguments, and so it could be a system call, could be not a system call. This indicate we call a constructor or not. So what do we do with this load file call API into ActivePDR? Essentially, we have this so-called ActivePDR, which is look like this, 128 bits for field over here. Each field takes 4 bytes, 32 bits. So its length, start, memory page offset. Essentially, it's used to pass the either the call data or the data in memory. So this is going to be load call data into ActivePDR first. So the call data will be loaded into the ActivePDR, and then we are going to. So this is the call data over here. So this will load not only just this data, but the whole call data, which is msg.date. So we need to adjust all these all this field over here, so that this file pointer can point to the can point to only this segment. Okay, so the whole point of using the file pointer is you are able to not copying the call data, but you are able to look at this piece, this slice of the call data. So you specify the offset, and then we are going to adjust the PDR adding to active. So this one is essentially make adjustment of the offset field, so that the offset is going to pointing to not to the MSG data, but pointing to the data over here. And then the next one is shrink to, which is going to adjust the length of this field over here, so that it's going to correspond to this call data of the input. Okay, and then the next one is we are going to prepare a file call API. So what is that? File call API essentially looks like this. Okay, so so it's going to take guess, going to take a short ID, going to take the forwarding mode, its constructor, its system. So all these fields, these 5 fields, is going to be filled out according to this structure. And by the way, over here, we keep the lowest 192 bits to be empty in the beginning, which is going to be combined with the find point over here. Okay, so this fed pointer, which is 100, 128 bits, is going to fill out this part and then combine together like this. So this will be the file call ABI. This will be the fed pointer. They combine together. We call packed file call ABI. Okay. So then and finally is they pack together. Okay. The file call ABI is going to be have a packed version. So that's how it's done in the code. So once we have done that, then the next thing is, I think it's very straightforward. We are going to let's start with the raw call. So we loaded a packed version essentially. This will load a packed version, and then you simply call the using the system call address, but the real calling is this one. Here, if you send some Ethereum, then the real calling is going to be the MSG value simulated first, and then the next call is going to be here. So we call these, then this will call these, and then this will call this. So it's a 1, 2, 3. Okay. In addition, we might need to forward the system call bit because the input could be a system call. So if this is true, then means this needs to be forwarded over here. So that's why we have to check if the system is true or false. All right. So that's very much for the raw call. Static call, easy. You call this one first and then call this one. This is the real calling. This one, call this one first and then call this. This is system call. Raw mimic call, you call this first, then call this, but we need to simulate who is the caller. So this is supposed to be the simulate the caller, MSG sender. And then we already talked about this, so we can skip it. So let's move on to the second library, system contract helper. And this one is the first one is try to call a system call by doing 2L1 call address. And so basically it's going to send a key value pair as a log to the L1. And this one is going to get the current code address. So that means this is the address of the contract whose code is being running. It might be the same as address as this, but it could be also different, especially in deleted call. In a deleted call, this will be the address of the calling. Address this will be the call address of the caller. So that's different. And that's how you also find out are we in a deleted call or not. I think we talked load the call data into active PDR. So this is simply a system call with this address. And what it's going to do is just, in my understanding, it's just going to load the MSG data into this, the call data into this, okay? And then from that point on, you have to adjust all these fields to make it pointing to the slice of the call data. So this is a pack, this PDR packed into active PDR, basically combine two of them together, combine the file call ABI together. And then this one is adjust the offset so that it's going to be added by this value. And this one is going to shrink, as the name suggests. So the length of the active PDR is going to be minus the value of the shrink. There's also a call for pack precompile parameter. So this one is going to just take all these argument, which is offset length, memory offset, memory length, and pre-compare interpret it, and then put them into a word in that format. Unsafe pre-compare call, it's going to cost like a system call called this over here, and then use the raw parameter as a word over here. Okay, so this is actually supporting all the pre-compare call address. Using this is the arguments, and then this is another parameter which is combine guest to bird and pub data to span over here. So basically you have a bunch of parameter over here. We have a bunch of parameter over here. So in this way, the two word can encode more parameters. This is set value for next call so that you can now set MSG value basically, which is provided over here. Using set this as a context. Another system call to event initialize address and the event write. So before you're going to write the event, you're going to call this one first and then call this one to write the real event that we want to do. And the event, this is going to be the value one, and this is going to be the value two, so two word. We can also get the matter that get Zksync matter bytes. This is the so-called matter is another struct which looks like this. Like this, it's a word. So with different bits encoding different thing over here. So a lot of information is very packed. So there are a bunch of functions which allows you to basically retrieve, different fields from one word over here. It's extraction. Okay. So, and you can also like get call flag by calling this system, get a call data PTR. Then you are going to return a PTR over here. I'm not sure if it's active PTR. And then there's also a get extra ABI data. This is getting the register, one register, two. There are 9 register for the virtual machine. And then you can check if it's system call or not by retrieving the call flags. And this one is check if address is system call. And then you can also bang guess by calling the unsafe precompile call that we discussed earlier. And this is a mimic call, very useful. So we're going to get the file call ABI prepared with all these in place. And then this is the pretended MSG sender is right here. And I think this is mimic call. We talk about raw mimic call first. So what is the difference? Mimic call. So I feel it's very similar to this one, but you guys can do a comparison between raw mimic call and this mimic call over here. Okay. Then the next one is false deploy no constructor. So the no constructor flag is going to be false over here. And then we simply do a mimic call with a propagate revert. False love, I'm not going to talk about this one. And mimic call with a propagate revert. So so it's going to be it's simply a wrapper of mimic call. And if it's not successful, we're going to revert with the error message. With the error message. Okay, so that's very much for the second library. The third one is system contract caller. This one is focused on system call. So this is an important function. In the same way, we're going to get a file call API prepared with the file call API. And then if it's no zero, then we simply call it a directory with the, this is a real callee, but it's a system call. So this is going to be true. So this is how it's different from a regular call. And then the next one is if it's not equal to zero, then we're going to call the MSG value simulator first. The forward mask is going to be here to see if we need to forward a system call flag. But this flag, I think, it should be always set because it's always a system call. And then the and then the environment is already, the file call API is already set as a system call because we always need to call MSG value simulator as a system call. Okay, so that's it. And then system call with the return data is just a wrapper to deal with the return data over here. So we're going to copy to the return data memory over here. So it's simply copy the return data from the call data area to the memory area. And this one is in the case of revert, then we are going to revert with the error message indicated by this. So, and then this is how we get file call API. I think we already use it. We're going to get the empty file API first, means the lowest 128 bits is going to be 0. We only fill the top one, so and then the lower one will be filled in later. So this is a got a file call API. This is most comprehensive function to prepare the packed version of API. And then this is just prepare the first part just over here. So just prepare the highest 4 fields, including a system call, its constructor call, shard ID, forward mode, gets passed. So only prepare the only prepare the 5 fields. 1, 2, 3, 4, 5 fields, and the remaining one will be filled later by the file pointer, which is down here. Okay, so this is all about system contract caller. So thank you so much. Have a nice day.